Alrighty, so here we go. So today I'm going to work on a waypointing system for the roads. So we have this network of roads and we want to figure out a way to get from point A to point B. There are algorithms people have written. I don't really know them particularly well, but there is an algorithm written for finding shortest path between regions in the main XCOM code. So I'm going to be making use of that and just trying to make use of that find shortest path to regions code and adjust it to something that we can use. Anyway, let's get started. So the first thing that's going to happen is with these path searches, so to speak, if the start path sort of has connected roads, so we have this this array called connected roads, which we keep just here. So those connected roads, we need something with connected roads we need to find the nearest thing that'll get us onto connected roads, and then we go from there. It's pretty straightforward if this does in fact have connected roads, but most elements won't be like that. So the first thing we need to do is find that case. So what we're going to do is we're going to iterate by class type. Float distance. So we're going to find the nearest strategy asset with the thing that we need. So what do we call this class? Global resistance game state G asset. Robo jumper. So yes, we're going to do weighting by finding the distance. So the point A from point B on the road, we'll get that distance as well, and make that work for us. Because it wouldn't be right to just calculate the number of road points that it hits. It wouldn't cost the correct amount. Right, test node. Okay, so if test node, so nearest node to self, nearest node to self is nothing currently, and so is the nearest distance. Right, so, time for A star. I don't really, oh, you can't see? I was on the wrong monitor. There we go. Alright, so would you believe it? I don't know algorithms very well. I'm a web developer, so sue me. So as I said, I'm going to follow off the sort of what this sort of stuff, that sort of the XCOM game state world regions approach, and I'm just going to sort of bumble through it, try and talk my way through it as I go, and hopefully we'll end up with an algorithm at the end that will do what we needed to do. Anyway, where was I? So test node. Connected roads dot length greater than 0. So let's get a nearest distance from this thing to that thing. I wonder if there's a geoscape entity thing for just finding a distance. I mean, it's not that hard. I shouldn't act like it is. That's what I wanted. Get distance. Okay. That's right there even. Okie dokie. So get distance between location, which is the location of this thing, and test node dot location greater than 0 and nearest distance. So and distance is less than nearest distance, then that means that this is closer than anything else that has been tested. So yeah, let's make nearest node to target. Sorry, not to target, to self. What else? So nearest node to self equals test node. And what I might do as well while I'm doing this is I want to avoid doing these repetitions. So let's do self distance, target distance. Yeah, I want to try and do more than one thing at once. So, because I don't want to do this iteration like excessively, because it's only going to get more expensive every time we do it. So let's do distance, self distance, and then distance, target distance. We just start them off at an absurdly large value so that we know that something will be closer than that. So nearest node to target equals test node. So this is to get our closest point and our closest point and our our start point and our end point in terms of the road network. And then after that, we will add to the start path dot nodes dot add item. What's it called? Add item nearest node to self, which starts off our our pathing system. And that start path dot distance will also equal self distance. So now we're knitted. What we'd probably do as well is also test to see if the distance between the target and self is actually shorter than this step. Because if the direct distance is shorter than both of these, then we'd basically bypass the road network and follow this. Anyway, so now that we've added to the search path, now I'm sort of going to follow the algorithm as it's stated and then go from there. So just give me one moment to sort myself out. Just going to copy that over. So yeah, we've got our search paths add item, and then we've got the search path. So let's just alter this as we go. So local asset search path, start path, test path, new path. Alright, so the test path is that one. The test regions, so that's not right. We're going to go test node, test paths nodes, test path dot nodes dot length 1, and we'll just follow along with what it says I'm supposed to do for this algorithm for now. All right. Okay, yeah. So it's not going to test long solutions. That's basically what this is getting at here. So nose dot length. And that's actually testing against dot length. So that's incorrect. We want to test against distance greater than 0 and test path regions dot length. So that's test path dot distance greater than our solution path. Yeah, so we're not going to test against that length. We're going to test against the distance. And then we break. So that would break the while loop. Okay, so that's a definite break. So I have to have a look at that at some point. Because I might be, there might be a possible optimization. Or it might be actually discarding paths. But I don't know my algorithms well. So I'll just sort of take it for what it is. Alright, did we find a possible match? Are possible regions? Where does possible regions come from? Oh, okay. That's the array. I don't want you. So that's where we test against whether this test region, whether the test node so if test node dot object ID equals target, sorry, nearest node to target, alright, then we have a solution. So we can then continue. So we're checking other paths at that point. Let's clean that up. All right, there we go. And then for each test node dot connected road, they're all state refs. Test node, child node. So yeah, for each of these, we want the global resistance, game state strategy asset, and now yeah, okay, so in the test path in the nodes, we see if we can find the child node, which is a strategy asset. And if we don't, we can make a new path from the test path by nodes.add item child node. Ah yeah, and then we got the cost here. But we're not going to go with that cost. We're going to go new path dot nodes. Oh no. Oh, pardon me. Okay. So we're going to get the distance. Child node dot location. Get distance between child node dot get location and new path dot nodes, new path dot nodes dot length, take one, the latest member of the path. I believe. Yeah, I think that's it. Okie dokie. So yeah, we add that distance. So new path from cost. What am I doing? New path from distance plus equal distance. And then we add the new path to that. Seems overly simplified, so I don't know. Might not actually be good. Alright, new path, start path, reset new path to match start path. And I'll just copy all these. Okay, so that's all the region checks. And then new path.nodes. Sweet. That might more or less do it, we don't know. Either way, all of this stuff will have to change. And this doesn't even work. What am I talking about? So the connected roads are not these. So that's the bit I glossed over, is here we need to check whether these roads point away from us. If they point away from us, then we can take it. So what we're actually testing is each of these roads. So let's try this again. Game state road. There we go. Okay. So we want to set a local for global resistance game state road. Child road. There we go. So we don't need that. We'll actually be using something else there. But anyway, child road, game state road. So that's what we're getting. And then we've got a road and we figure out whether it's from or to is sort of the geoscape entity's connection. So from child road dot state ref a dot object ID does not equal test node dot object ID. Then we've got the right one, we use that. Otherwise we use state ref b, which is the other side. Alright, so now we do this. So child road dot state ref a. Fix that. Now we've got state ref b. And now we're good. So we've got the right child mode to work from. Yes. So now what we can do So we're not using a region chain anymore, we're using a chain of global resistance game state strategy assets. So this bad boy returns an array. Search path. Yeah, it's an array of global resistance game state strategy assets. Node chain. Alright, so node chain dot length greater than 1. For node chain path region. Pardon me. Path node is what I want instead. Yeah, so this is when I was using the region links to do my thing. I'm not going to use the region links anymore, so this actually gets a little bit simpler. So what we're going to do instead yeah, we don't even need to do that because we can literally just say, all right, the path region is going to give us a location and we're going to use the same speed. So add waypoints and we're good to go. So this track boolean there, that's to follow the asset once you sort of get it into sight. We won't worry about that yet. If node chain, yeah, okay. So we got ourselves a node chain. We're not worrying about the region chain. Instead, we're literally just going to go node chain equals get shortest path to asset and make that the target asset. Now we can get world region, path region, region template, and traverse. We don't need any of those, we just need the path node. And its location, and I think we're good to go. I'm just going to test this, see if it compiles, and then we'll carry on. I should probably just run a compiler the first time I open this thing anyway. Save me having to wait the first time I finish working and want to see what happens. Okie dokie. hopefully just a few typos there. So first off, line 31, forgot to put that in place. No, there's no errors, probably because it didn't get that far because of the so we have to wait until this one runs through. Alright, 234, nearest node to target. Oh, whoops. Let's get rid of those. Alright, and build again. Alright, more build errors. Type mismatch and call, get distance parameter 2. 39G. Oops. Thank you, static typing. 173. That's not where I want to go to 173. It's over here in the city strategy assets. 173G. And I forgot to close these lines. All good. Anything else? Let's run the build. Oh, we've got a build. Lovely. Alright, I'm not going to run this because nothing's actually going to run this code yet. But close that, we can have a look at the next phase. Actually, I might check one thing. I will run it up. Oh, X comes over there. Sorry. There we go. Alright, hopefully everything doesn't crash in the startup. Okay, we're still alive. Alright, we need to burn some time. I might try and re-enable my scanning. Let me just check my code, see where I disabled that. go. Alright. Let's kill that. We'll run the build again. And we'll see if we can scan this. Kick that away. Alright, let's scan. Okay. Well, it doesn't look like anything's following a path or anything. Building path 2. Okay, so pretty much everything is having a straight line path. So yeah, we gotta fix these up. Okay. Alright, city, strategy, asset. Alright, so we will only do a dispatch for cities that are, there we go, control zones. Just to remove some of the display. Alright. So get city display name. We want to get not the display name, but the city template name. Just because I'm not guaranteed I haven't gone through and done all the localization for all the cities yet. So let's drop that. Set waypoints to asset. City at a standard speed. So got this pathing check. Then waypoints to asset. Done, do nothing. Alright. And the path is always 2 currently. Node chain dot length, yeah. Yeah, so I'm gonna have to just go through and get some of these nodes just see whether this actually is searching. Test node dot distance. Test path rather. So I'm just going to get some information and then we'll make some decisions once we got from there. Alright. Checking solutions. And we'll just make sure that our solution path actually has a length to it. Okay, we'll drop in those statements and we'll see how we go. Alright. Game state added to node. I wonder if what has happened there is all the nodes have dropped. Alright, I have to roll back in that. But I wonder if what's happening early on in the piece is everything's being dropped. Sorry, by everything I mean like all the connected roads. So there's actually no connected roads length on any of these items. No road. Okay. Build road. Access none game. Build road. Ah, okay. Here we go. So build road and none's happening between them. So I reckon the connection is going bad. Road asset. Get reference road from road to. Road node, where's it getting?
Hey Daddy.
One moment.
Can you ping
One moment, buddy. Alrighty, and we're back. So, she ain't building the roads. Where is that script warning coming from? Must be happening in here. Because at that point, what happens is there's no connected roads. Checking solutions. One arrived solution at distance of... yeah, so that'd be a direct flight. Checking solutions, building path. So there's only one solution. And it's based on it being already at the right, arrived at solution of distance of, yeah. So that's with no connections whatsoever. It's literally just closest to... Yeah, I don't know. Oh, that's one problem at a time. So there's 4 cases where it's not working. From get reference to get reference. The roads even show up. They might have, might not have. So the unfortunate thing is this code might not even run. Road from roads length road from connected roads.length. Let's check that out. And road 2. What else can we get? It'd be really nice to step through this with a debugger. Might be time to set it up. Alright, that should give me enough information. What I might do as well though is try to get a bit more from this. Road pos B. Road connection. Alrighty, let's try that. See what happens anyway. Alright, run yourself up. Alright, well we got roads. That much is true. But still a bunch of things broke. Road pos A and road pos B. There's some issues in there, I guess with state object reference. Oh, that's right. There we go. So we do have roads, but the issue is we don't have meaningful paths. We're going to have to get that from the log. But either way, yeah, they're all just direct sends, unfortunately. Okie dokie. Alright, give me a bit more info, please. Oh, that must be a max number right there. Yes, indeed it is. So my test is bupkis. So what I should instead be doing is the -1 check like it was doing. So log testing nearest node. Let's break this up and go distance less than self distance or distance equals -1 or self distance equals -1. Target distance. Find closer self node. All right. Let's try that. Target distance here. Hopefully that equality check works. Floating point. Let's do that instead, just in case. Okie dokie. Let's run a build. Alrighty. There's probably going to be just a few back and forths testing this to figure out where the problem actually is. This is one of those cases where a step debugger would really come in handy. I should probably set one of those up at some point. But I'm not going to do that on stream because setting up tooling sometimes takes a while. Alright, let's kill all these. What am I doing? There we go. Nope, no good. Alright. Give me the money. There we go. All right. Solution of a distance -1. Oh, that's not good. Okay, so found closer target node. Yeah, so something's breaking out early. What's going on here? Oh my, that's just dumb, isn't it? That's the thing I'm supposed to be doing. Right. So it says those, and then we have path, and then we're checking. But does it even run the tests? Let's see. So it goes through all these target nodes, which is good. Testing nearest nodes. Found nearest node to self. Nearest node to self object ID. And also check found nearest node to target, which would be nearest node to target.object ID. And it's meant to keep going until it finds test node to object ID. Now, if that's a -1 check, then that would probably be why that's breaking. Search paths. And does these put, yeah, these are meant to put them back on to the path. And these fan out. Alright, let's try that, see what happens. Alright, go away. Okay. Say goodbye to you. And then open up a new log. Okay, that's ugly. Nearest node to self and nearest node to target are exactly the same thing. So it arrives at a solution of a distance of 0. This is no good. It's Paris to New Delhi, not even close. What did I do wrong? Probably something dumb. Five, 4, 4, 5, 4, 7. Is it ever something different? It's never something different. That is worrying. So I'm not sure why, but both of them are exactly the same. Location, test node, location. And we're testing from here to there. Oh, that's dumb. That's really dumb, of course. So we've got to test distance. That's very, very dumb. Distance and then asset dot location for this one. I'm so dumb. Alright. That's what you have, what you get trying to optimize before writing working code. Alright. So that should work now. And now it shouldn't break immediately because it's not the same test being run. Okie dokie. Oh, let us have a sound.
Excitement continues to build as city centers.
While we prepare for new operations and continue our research, we can pass time by scanning at sites like this one. On your order, we'll start our scans on the surrounding area.
Well, the search is working. Must be recursing. Yep, definitely recursing. Okie dokie. That's all good. So we can kill that. Arrived at a solution of a distance of 0. Ah, jeez. That's no good. Okay, let's start from the top. So go convoy, which will be the first instance of this being called. So I found nearest node to self as 544, nearest node to target 571. And it starts this node search. It starts working its way through it. Alright, so I need more information. So now that we're into this part of the system, let's get a bit more information. Okay, we'll keep that one. Test node, object ID. Test node dot connected roads dot length. Test path nodes find child node. Okay. Adding nodes. New path dot distance. Child node dot object ID new path dot distance. All right. Yep. Let's see if we can use this to get a bit more information. Find out why it's not terminating. Because removing paths up there, search paths are being added there. Theoretically, these should, at a certain point, get to where they need to go. This only is true if it's randomly choosing a place that is actually possible to reach. Which might... I'm wondering if there are some missing roads that we'll need to put in. Yeah, that might be an issue. I'll do a double check and see if there are some missing roads. Oopsie daisy. Alright.
Research, we can pass time by scanning at sites like this one. On your order, we'll start our scans on the surrounding area.
So I omitted some roads because I knew that if they existed, yeah, the ones that cross the date line have been omitted, because while they were there, it was impossible to actually get there. What would happen is it would flip over and the paths wouldn't draw properly. So I just sort of figured I'd kick the problem down the road a bit. Okay. Alright, so we're going to get stuck in a moment. But this is good. It's giving us some information. And some nasty script logs. Okie dokie. Take that. Have a look. The distance is never increasing for some reason, which is bad. Nearest node to target does not exist. Also bad. Come on. Well, that was done too. Okay. But even so, it was traversing these paths and not actually getting any distance to them. So something's wrong there too. Self-distance. Self-distance. So let's just test that. And then maybe the plus equals don't work with floats. In which case I want that to equal new path dot distance plus distance. Alright. Okay, let's try them again. Alright, round 50 or whatever it is. Oh, good. Error 264. I forgot a close. To close a statement. Equals test node. Another dumb thing. Alright. Honestly, I'm further along than I expected to be. I expected this to, well, it would have, like, I mean, it might take a lot longer than this, but I expected this to be a much harder one. If this pathing algorithm largely works for me, then I'll be pretty happy. That said, it might be a bit too slow in Unreal Script, but we'll probably just have to make do with that and avoid calling pathing too often. And we can spread that stuff out. We could like make sure that like all the sort of the dispatch cycles are sort of all spread out, so it's never never trying to do all this pathing for like 10 different dispatches all at once or something.
We can pass time by scanning at sites like this one. On your order, we'll start our scans on the surrounding area.
What we might also do is like set up supply routes. So instead what it does is the supply route gets, like, it says, all right, we're going to start sending stuff to this place, and then it uses that information. Yeah, uses that information. Once it's done the parving and it's successful, it can like just hold on to that information. Okie dokie, goodbye. And yeah, you can hold on to that information and say, all right, so we've got this established path, and like if if one of the nodes in the path gets taken over, then we can deal with that. Come on, why aren't you adding? So one case of convoy, start path.distance, searching. Okay, so it's itself, so it knows it's not going to go any further. But that shouldn't matter, because this distance is something, surely. Just going to add some more stuff in. So origin, object ID, and then target, which is asset.object ID. Asset, okay. And like even if it doubled up on itself, it shouldn't then get stuck and be incapable of adding paths, because it's clearly adding nodes here, but it's never arriving at an endpoint is the main issue here. It just keeps on running around. I do wonder if the equality check is working though. But these should hold some equality, because they're all using object ID. So the history, the game state, get game state for object ID, hopefully like those subsequent ones should be like equal. So a find check should hit them. I don't know. Oh. That explains that one. All right. This is the problem with following someone, like following some code and like just largely copy pasting it. Sometimes you just miss some of the little details, and I certainly did there. I have been a bit distracted this morning, evening, whatever you want to call it. Show me the money. Of course, there is no guarantee that any money will be shown, but we'll see how we go.
On your order, we'll start our scans on the surrounding area.
Wait, come on. There we go. Well, we're not getting anywhere. Ooh, okay. Maybe we do. Maybe we are. So here's where this is probably going to get a little trickier, because this depth, like, it's pretty crude, this approach to searching the world map, and what's probably going to have to happen is, instead of searching like that, so yes, it successfully did everything, and I can't count on the console logging being the reason why this is running so slow. So what I'll probably do is bump up the delay between each of these so that we can be sure that the paths sort of run to fruition, but then we're going to have to figure out some way to make it more efficient. And that's probably going to mean making the searches discard, like they'll do a region-based search first, which is relatively quick. Region-based search first, and then once it knows its region path, it'll know, okay, so I need to get from this region to this region, and from this region to this region, and it will use the connects region information to figure out, where each of those those points are, and find the fastest way there. But it's otherwise we're looking good. We're making progress. Let us look at the city strategy asset. So we will set next dispatch to be, instead of 48 hours, we're going to set it to be like, let's go 24 times 12. That'll give us a decent amount of time to observe the paths running. But that's promising. It's a start. I do wonder part of how the algorithm's working as well. I mean, this is where, yes, it would be better to run A*, so I might have to do some learning, find out how A* actually works and implement it. Because this depth, this method of searching means that it'll just keep on getting longer and longer at the bottom, and it won't ever sort of respect the fact that it's gone way too far in this tree to get to where it needs to go. So it's going to keep on going deeper and deeper and deeper and not discarding anything. So the algorithm that they made for region lengths is going to be a bit too slow by the looks of it. So while this is running up, I might
Excitement continues to
find
build.
some resources on implementing A-Star. Alrighty, round we go. In 1 or 2 days, the pathfinding shall begin. There we go. Alright. Come on. I don't think I'll implement A-Star tonight. I'll probably call it a night. I'm happy with the progress, and yeah, provided this works, it should work. It should find its path ends it did before, so it should do it again. But then once it's done, it should. Yeah, that'll give us. There we go. Nice. Sweet. Okay. That's looking very good. We have...
An urgent communication coming in for you now, Commander.
You have made considerable progress against the aliens over the past month, Commander. I
Sweet.
hope that your ongoing efforts will only lead to further success.
Commander, we have intel suggesting the aliens are working on developments that threaten our ability to stop the Avatar project. We can conduct guerrilla operations to disrupt one of these efforts, but we'll have to choose carefully. We don't have the resources to intercede everywhere.
Excellent. Alright. Things are looking good. Alrighty, so let's commit that and we'll call it a night. Yep. Okie dokie, git bash. Documents, my documents. Nope, that's not what I want. I want for access. XCOM, global, git status, git push. G'day there, Tizano. Did you get my invite, by the way? I'm just about to finish, but hopefully you got my link through. Otherwise, I'll send through a Discord link again. But either way, I'm finishing up. I got what's it called, pathfinding working, but it's really slow. So next we'll be implementing something like this bad boy. Oop, everything else went away. But anyway, I'll be implementing something like this guy to make things work for me, I think. But anyway, until next time, I'll see you around.